Okay. Now, that was a fantastic testimonial for how our solution is helping a customer. I think that kind of nicely sets up for this small session that I got on Teamcenter. How many of you here are using Teamcenter? Let me just, I think this crowd is internal crowd, but on the customer side, how many of you are at least planning to look at Teamcenter in the next, let's say, few quarters or immediate future? Any plans, or how many of you have attended Teamcenter sessions before? Let me put it in. So it's all completely new for you, most of you? All right. So I would try and keep this session very simple, very short. This topic can actually run for days. PLM is a huge topic, right? The entire world is moving towards digitalization, right? I think especially post-COVID, everybody is talking about Industry 4.0, smart manufacturing, digital threads, digital enterprise, right? Digitalization. All these are basically what we are trying to, most of the customers, what they are aspiring for is to kind of go towards a complete digital cloud-based setup, right? Today, what I've got is an introduction or a starting point as a starting journey on how you lead towards that goal of full digitalization. The starting point is, of course, PDM, right? Product data management is basically the starting point. Gradually, if you look at PDM to PLM to a digital enterprise, so that's how you can plan yourself. This is probably the most easiest thing as far as data management is concerned. It's predominantly talking about a next step towards your path. Like you're mostly into managing CAD data, like mechanical, electrical CAD, etc. So how we can actually streamline that and put together a platform which will help in collaboration. That's what we are talking about. So Teamcenter Rapid Start is nothing but we have made things easy for people like you to take and start the implementation, right? With something like a pre-configured setup of a lot of what we do within PLM, right? So that's basically what we call it as a rapid start. So let's just move on. I think most of us know, irrespective of the industries, any industry you take, the complexity of the end product is really getting very huge. Like you can name any of this, right? The need to be smart, need to be connected, the quality aspect of it, cost pressures, right? Most of the products today got a lot of electronics content in it, right? Electrical, electronics, software. You take, let's say, an EV vehicle, it's actually a mobile computer, right? And you look at the dashboard of any of the latest cars that you do, it looks like a cockpit, right? It's all very jazzy, completely digital, right? So gone are those days where we talked a lot about mechanical designs. Today, I think every single thing, be it a smartwatch to any complex product that you talk about, has got huge amount of electronic software components. That's where the thing we talk about smart, connected, etc. It kind of opens up to a huge amount of challenges that you have to start addressing. If you look at any enterprise, right, you got these different silos, right? You got the design organization, engineering team, this is a manufacturing planning team, the manufacturing engineering team, then it's a manufacturing execution setup, and then finally the after sales service. And most of the time today you are focusing on this part of it, and predominantly just about designing and getting the product out. Predominantly focusing more on using the tools to get the job done, right? But as you grow, right? Today you may have some 5 to 10 designers. Let's say as the company either acquire or grow with new products, the 10 may become 20, 20 may become 50. I think as the organization scales up, as your business grows, you will start getting introduced to these areas, right? So you got, let's say, mostly today it's called CAD BOM, right? The next would be engineering bill of material. Then subsequently it will be manufacturing bill of material. Then there is the concept of bill of processes. Then there is a need actually to transfer this bill of process, which is manufacturing plans, to ERP systems. Then there is a need actually to work with manufacturing execution system to send this manufacturing operations to get it manufactured through the help of MES systems. It doesn't stop there. How can you improve the quality of the product? Every single thing that gets done on the shop floor has to be registered, recorded, the genealogy of, what is the serial number, who has built, what is the lot number, etc. has to be registered. Because if something goes wrong, there's a lot of recalls happening in different, let's say even automotive, right? Suddenly there is a recall. So how do we know which particular lot has gone wrong? Quality, right? So the after sales is also equally important, where if you discover a problem, how do we connect it back to the design? That's how we can enable the continuous improvement of the product, right? So today, predominantly, it's all silos. What I'm saying here is, I think we start getting into how we provide a platform where we can seamlessly, handshake with different disciplines. So how do we start? Where do we start? We all know the challenges. The complexity I talked about, I think the silos needs to be connected, I talked about. You are completely, new. You just are trying to, get started, right? So it's very important for you to answer these questions. Where do you start? Where will you go next? How fast you can get there? And what will cost? It depends. Each of this, the answers going to be extremely different for different organizations. It all depends on the maturity level of the organization, right? So there is no like a general answer to these questions. But PDM, you can assume that PDM is the easiest place where you can start, right? That's what we are going to start looking at. So if you look at the CAD data management practices, a survey from Aberdeen says that about 72% of the respondents say that they're just using file servers. They don't even have a proper revision management for all the CAD designs. There's no proper check-in, check-out, no central repository. About 43% says that still at a desktop level, just save it in a central, maybe a common server, something like that. Small number of people, about 34% says that a single PDM, and still very less number of people only are looking at a multiple product data management system, right? You can see survey says that still a lot of people are in the file server. So what is the difference between non-PDM environment with a PDM environment? You can see that it enables quite a good amount of reuse of existing data, reducing the development time, eliminating quite a number of non-value-added activities, right? From a reuse standpoint, if you look at feature reuse, a lot of reuse actually. I'm going to talk more about what are the kind of reuse that we can facilitate. But generally, I think we are pushing for quite a number of reuse. Just to summarize quickly on PLM, while all this complexity, if you can just get rid of, what is that simple 3 things that we can look at from a PDM, right, point of view? Single source of product data, single source of truth, we call it as, right? People get to see the latest and greatest of the information at any given point in time, anywhere from the world, from any device. Always looking at the correct version of the design or simulation or manufacturing information. That's a very important thing. It's pretty simple actually. If you just set up a foundation, you enable single source of product data, facilitate simple process execution through automated workflows. Like no more manual transfer of information from one discipline to another discipline. Simple workflows can help to automate things moving from one step to another step. And there is a traceability in terms of what is happening, process workflow. And the third thing is about getting all this CAD data managed, right? MCAD and ECAD. I'm going to talk a little bit about the MCAD and ECAD. So if we just look at these 4 key things as a takeaway for you, is managing the designs, mechanical CAD, electrical electronics CAD, managing all different kind of documentation, managing the pre-configured workflows, like it can be an NPD process, APQP process, NPI process, right? It could be change process, engineering change order, engineering change request, all kind of engineering change processes. Managing project-based groups and roles and disciplines in terms of how you organize the organization and how we can ensure the data is protected among different groups, for example. Basic foundation of PDM is, like you got a lot of design informations, right? How do we make each part right? Registered in a PLM system or a PDM system with all this associated information always, maintained well with a proper revision control. So every part, you can say, when it gets stored in a PDM, it becomes an item, and you can see there is a requirements, there is a change, there is a documentation, cost information, schedule, software, models, geometrical models, all this information goes as an attachment with everything having a proper revision control. So that becomes like, a single source of truth for a particular part with all associated information. Just look at a quick demonstration of how a Teamcenter manages the data. So you get into Teamcenter, it's a very sleek interface, we call it as an active workspace interface. He started looking at the kind of information that is like basically a typical search, and he's just nailing down the search to look at parts and start comparing the parts from the search results. Quickly able to see what are the different parts that are available, matching his search criteria, and then get into one particular assembly and just start looking at the details of what are the other associated information I just showed in the previous slide, right? You take a part, there are so many other information attached. Go to an attachment, you got all this information, everything properly revision controlled. Very easy to pick this information. Another important thing, you stand in a particular part, you've got a lot of networks here. How each of this is all impacted, or where it is used and where it is referenced, from a association standpoint. You got one assembly, one part, which is the parent, which is the child, what are the associated other parts, can easily be navigated. Then from there, you go into an assembly of that part, and you look at the bill of material, which is basically an engineering bill of material. Then at the side, you got all this information, like values I talked about, visual graphics, the metadata, number of revisions it has gone through. You take that revisions, let's say this particular part has undergone 2 revisions, revision A and revision B. Just quickly look at the comparison on what has changed in revision B. There are 2 parts that got added. So just quickly look at what's the change from a change management perspective. Just move on quickly in the interest of time. So you look at graphic, another thing, important thing, whether it's Solid Edge or NX or any CAD that you use, the moment you save that, it creates a lightweight version of the CAD geometry. We call this as a JT, most of you might know. It's a highly lightweight, compressed format, which yet it has got all the precise information in terms of measurement, everything. Very, very important for you to start leveraging this lightweight JT into putting all your PMI information. It becomes a 3D PMI. And you can see that you can cut the section, you can look at, do all sort of analysis without getting into the native CAD. Right? You got other documentations, like say you put annotations for the drawing, right? You can actually initiate a change process, for example. If you want to really put an annotation, say, hey, this is not okay. From revision B, now you go for revision C. What is the reason? What is the starting point? You just capture that and initiate the process. Okay, let's move on in the interest of time. So PLM, one of the very important thing for you, when we talked about the complexity, it's about making sure that the mechanical, electrical, wire harness, electronics, and also equally important is ALM, Application Lifecycle Management, software, which is not mentioned here, but that's also important. Why I'm saying, you take iPhone, for example, right? That's an enclosure, which is designed in one of this CAD. Then there is a PCB board inside, designed in one of this CAD tool. Of course, it goes through a schematic, and from a bare board, it gets, ECUs and all these things will get added on. And in a chip, there's going to be a software that's going to be flashed. And that software itself has got its own life cycle. There is a requirements for the software. Somebody develops the software and flash that software into these chips. There is a mechanical, there is a board and chips, etc. designed, and there is also cables that connects these things, right? In a phone, it's very simple. Imagine an aircraft. In an aircraft, there is a cable running from a cockpit to each of the seats, for example, or the landing gear. Imagine the wire harness complexity, right? And there are so many subsystems, right? There's a fuselage, there's a landing gear, right? There's several subsystems all put together becomes a system. So that is the kind of complexity that we are talking about, ranging from a small smartphone to an aircraft. So you still have to address all this different integration of CADs. I'll just show a couple of examples, one a mechanical CAD, which is solid edge, and also one electrical CAD, okay? So I think since we have seen most of solid edge, I'll just keep this video pretty short here. I don't know, just what you can see here is there is actually a menu called Teamcenter embedded here. Here you can see this next to the view. And once you hit that, you get almost everything exposed within solid edge. It's the same thing for NX or any other CAD, for example. And you actually can browse through anything that you want. Like say in this case, they're trying actually to reuse one of the part. You got an assembly open. There's one part that you're trying to look at if there is a possibility of reusing that part. Instead of creating a new one, just look for reuse. Look for this particular specification. Just try and pick that part, add it to the session, and finish the workflow. This is a simple example of, without getting out of your CAD tool, you've got everything that you want to do in terms of reusing from the library, check-in, check-out, anything that you want, you do it in an environment without even actually opening a different browser. So that's basically on. You can see this, right? I mean, everything that you do within that, it gets saved in Teamcenter, and you've got documentation done pretty comprehensively. Same similar thing for pads, which is actually a schematic design tool from Mentor Graphics. You just keep seeing, let me just play this. For some reason, I cannot fast forward, but I'll just show you. You open a pads environment, there is actually a menu here, which directly get access to Teamcenter. And from Teamcenter, again, similar thing. You just want to reuse one of the schematic assembly. Just open that schematic assembly, just run through it, look for reuse possible. Okay, it doesn't, the moment I just forward, it goes back to. So I think the same concept. In the interest of time, I'll just move on. I think you got the message, right? I think it's about like, any of this CAD tool, be it wire harness or electronics or mechanical, you got the tight integration brings in that menu embedded, and you just do everything within that environment without getting out of individual CAD tools. If you look at, I initially talked about, there are a lot of documentation that you have to be worried about and manage the documentation. So from a life cycle perspective, where does it start and how do we get through all these different documentation needs? Starting with the requirements. Requirements, it's very important to be managed. Requirements, then you've got this 3D model design, then we've got analysis. Analysis is also equally important, like, how do we author the PMI? Over designing is a cost to the company. Under designing, there is a risk in a PMI, right? How do we optimize the PMI? Again, take advantage of some algorithm built in some variational analysis tool, right? You can just get, recommendation in terms of what should be the right upper limit and lower limit for the tolerance, for example. Take advantage of those. Get the documentation automated, done it, right? Then you push it to manufacturing. Anand Fadnis morning talked about, how 3D PMI can actually influence or, make the tool path generation seamlessly, possible. Could actually be passed on to CMM machines, for example. And then from there on to, let's say, controllers. All this documentation with the help of these tools you can make. Then I think I talked about 3D PMI. Take the 3D PMI, push it to a supplier. Supplier has got everything that he needs to actually to provide a good code. Also equally important is PPAP process. Also, can actually take advantage of JT. Then inspections. Then production, like we talked about the technical data package, like, if you have all this documentation go all the way up to creating an animation view of, what the manufacturing process should look like. That actually can be pushed to the shop floor, like an electronic work instruction. Also equally important is if the product is complex, how to assemble, disassemble during the operational phase of that product, the service manuals, etc. All these are documentation, right? And a simple documentation, we all know that we use Microsoft Word, right? Be it Excel or PPT, you can again see a very similar approach of a Teamcenter menu getting embedded there. Just pull in, reuse the documentation, use templates, create the documentation, save it. This is the kind of difference that we bring in, irrespective of any tools that you use on a daily basis. Most of the time, it's Microsoft CAD tools and simulation tools. You can see that menus getting embedded everywhere. That is what we are talking about in integrated PDM environment. Got it, right? These templates actually can provide the placeholders to complete the documentation, save it back to Teamcenter. Got it, right? So what if you make any change? The next point, we talked about what? CAD management, right? Now the next important thing that you need to take away is change management. You're working on some information today without a PDM or PLM environment. How are we going to handle the change? Change may impact many things. For a part or assembly, there are associated drawings, simulation, customer specs, solid models, user-defined data, so many different type of information. It's very difficult if you make a change, a revision A becomes revision B, we should quickly do an impact analysis to understand the impact of the change. Let's say a form fit function change. What kind of impact has got for other associated data. That analysis, it's impossible if you don't have a structured information, right? Agreed, right? So that's an important thing that you all have to keep in mind. And that calls for a need to have some streamlined workflow, some standardized engineering change processes, right? To automate, like it can be a fast track change, it can be a full track change, depending on the complexity of the change, right? So here you can look at, we manage the change through statuses, and you got all the different transparent, traceability information, etc. And the next thing is, when you are talking about an organization, it's also important actually to organize the teams. I talked about disciplines, roles, and groups. How do we ensure that certain sensitive information are protected from one team to another, for example, if needs to be protected. There's some roles and groups. Again, this comes pre-configured. If you don't know where to start and how to organize, for a small and medium customers, this could be a standard, simple organization, which actually you can start using and you can add on to it. It's getting right? So I am just kind of trying to get to last 1 or 2 slides. Rapid start, as I again just to reiterate, this is a pre-configured. The pre-configured from the standpoint of having certain workflows, very few which are required for an organization of your size. So it's very fast, flexible, and it can actually provide a platform to scale further up. And how do we scale? A PLM is always basically a starting point, right? And we actually can grow this PLM. How do we grow? A quick PLM payback, if you look at, we talked about it, right? So if you have a PDM, the big difference that you're going to see is there is an improvement for time to market, number 1. Number 2, there's going to be definitely reduced errors, and there is an improvement in quality metrics of your end products. Number 3, a huge emphasis on reuse, we talked about, right? That's going to help in achieving certain KPIs that's shown on your left-hand side. Now, once this is settled, then you can look at really extending it to PLM. So the difference between PDM and PLM is PDM predominantly focusing on document management, basic CAD management, basic, let's say, workflows, change management. That's about it in PDM. Now, if you look at what else I can do, now it actually, you can start looking at connecting it to manufacturing planning, manufacturing execution, ERP systems, let's say supplier collaboration, product cost management, service lifecycle management, mechatronics. There's so many different things that are required as the complexity of the end product that you make grows. It may not be the case today, but 10 years from now, I think it eventually you will get there. That is when I think PLM will open up for a lot of other integration possibility, which will result in, if you look at the metric, now metric changes to revenue metrics, overall quality metrics. it's like achieving the objective of the company's vision and mission. So that is like, naturally you can change your mind, you have to change your mindset to, how I can help towards achieving the organizational business objectives in the long run. That is what PLM actually will help you to achieve. So we talked about multicad, we talked about single source, we talked about growth path, we talked about fast to deploy, minimal excellence. So I just complete with this slide. I kind of, trying to just compress and finish it off. I don't want to extend too much. But this one thing I just wanted to highlight as a last point. We have talked so much today. Accelerator is not a product, it's in branding. It's actually an umbrella under which you can see this ring that comprises of mechanical, electronics, simulation, manufacturing, operations, IoT. There is each of this, it's all a big domain on its own. This is represented by different solutions and also an integrated suite of products. So accelerator, for any industry you take, a combination of all these products definitely will be able to satisfy today's needs, and also at least I would say a 5-year roadmap we should be easily, comfortably putting for you, right? So that is the kind of, I would say, breadth and depth that we have with so much acquisitions that we have made over last decades. Vineet showed in the morning, starting from, there's one, past 15 years record view. So accelerator actually is basically a result of all that acquisitions, and it's all well integrated. Most of the acquisitions will take some time, but now we are standing in 2023 with most of the products very well integrated, deployed in many different customers. All big OEMs been using Teamcenter, right? And we are now proud to say that some big wins. I want to take names also, like, after Daimler moved from CATIA to NX, for example, recently HKMC, Hyundai Kia Motors, also decided to move from Creo CATIA to NX, for example. And you know that Solid Edge and NX all kind of, coming together. And the way that we are going to market is, we are also introducing some new bundles called Solid Edge Mechanical Design Bundles. For us, the NX and Solid Edge are brothers. And we position Solid Edge for design-focused workflows and NX for multidisciplinary workflows. You do some basic solid modeling in, let's say, Solid Edge, and for complex needs, you take that same parts very seamlessly to NX, for example, finish off your assembly needs, etc., and then from there on, you take advantage of, let's say, MBD for model-based definitions, also MCD for, let's say, kinematic simulation, and from there on, you actually want to integrate to CAM and do some, let's say, optimization with Cinemeric controller for CAM program. Do that. You can take the Renisha machine and, do a CMM program, you can do that. So now I think the focus is, for you, current needs, Solid Edge is very good, but as your needs grow, I think we come up with some bundles which will seamlessly, help you to really achieve, all we are talking about. So I'm talking about, like, your needs for the next 5 to 7 years. We are well covered, right? Today I'm just kind of giving you an introduction to this. We'll continue to teach you in the next few years. And as you start understanding the needs, you are basically the window for us actually. You guys go back and look at, what strategically you have to do for your organization. And we come back and, sit together and put up a roadmap for you. That's how it's going to work. Because otherwise, this is a big topic, right? My objective is to kind of give a little bit of awareness on need for you to start looking at it. Today, don't need to worry about the complexity. PDM is very small. You should be doing it now. And it doesn't stop there. You should start looking at your 3 to 5 to 7 year roadmap and look at, how your competition is really getting prepared, right? So with that, I will just stop and I'll just pass on to